Alright, ladies and gentlemen, welcome to the second of three videos covering the topic graphing rational functions. Again, this is from Chapter 2, Section 5 of your pre-calculus book and is one of three sets of notes from that section. In the first video of the three for this particular set of notes, we talked about how to find vertical and horizontal asymptotes for a graph. Now we're going to actually graph. So here we're going to graph the rational function y equals 4x plus 1 over 2x minus 4. So we start off, first step is to figure out the horizontal asymptote. The degree of the numerator is 1. The degree of the denominator is also 1. N is equal to d, which means that the horizontal asymptote is y equals a over b, where a is the lead coefficient on top, which would be 4, and b is the lead coefficient on the bottom, which would be 2, which means the line y equals 2 is our horizontal asymptote. So we can go ahead right now and graph a horizontal asymptote at y equals 2. Okay, this is the line y equals 2. That is our horizontal asymptote. Vertical asymptotes, we simply need to look at the denominator and realize that it factors. We can take the GCF out of it. We're simply asking ourselves, where does the denominator equal 0? Well, we can take a 2 out of that, which would give us x minus 2 and 2, which means that we have one vertical asymptote when x minus 2 equals 0, or at x equals 2. So we can sketch that as well. We just quickly draw ourselves a vertical line at positive 2. And that line is our vertical asymptote. This is the line x equals 2, which is our vertical asymptote. Now, this means that we have two sections because we have one vertical asymptote. So our graph is broken into a left half and a right half by that vertical asymptote, which means that we're going to create a table of values. And because these are both considered to be outside sections, we're ignoring the horizontal asymptote. We have two sections, a left section and a right section. We really should only need 4 points in theory. We need 2 points to the left of x equals 2, which would be like, I don't know, 1 and 0 would probably be good numbers to use, and 2 points to the right, which we will call those, we'll use 3 and 4 and see if they work out. Now you notice my chart is actually far bigger than that because I may need to do additional points to get a good picture. So what I'm doing is I'm plugging 1 into this function for x. So when I put 1 into this function, I have 4 times 1 plus 1, which is 5, over 2 times 1 minus 4, which is negative 2. So that'd be negative 5 halves, or negative 2.5 if you have trouble graphing improper fractions. When I plug in 0, I have 4 times 0 plus 1 is 1. 2 times 0 is 0, minus 4 is negative 4. So that would be negative 1/4, or negative 0.25. So if we go over here to our graph, and I'm going to graph these in purple, and we graph 1, negative 2.5 would be halfway between negative 2 and negative 3 on one line where x equals 1. And then 0, negative 0.25 would be below the axis, but just barely. That should tell us pretty much what this looks like. I mean, that means that it's going to come in along that axis, it's going to pass through those 2 points, and it's going to exit or along that asymptote and exit along the asymptote. Because again, these are examples of problems that are very similar to our reciprocal functions. So the outside sections of these graphs should look like our reciprocal function. They should hug the asymptote. For 3, we plug 3 in up here. We have 12 plus 1 is 13 over 6 minus 4, which would be 2. So that'd be 13 halves, or 6 and a half. And for 4, 4 times 1 is 16 plus 1 is 17, over 2 times 4 is 8, minus 4 is 4. Well, 17 fourths is 4.25. So we graph those points. 3, 6.5, about right there. And 4, 4.25, would be just above 4. So again, that's going to tell us the same sort of deal. It's going to come in along that axis. It's going to pass through our 2 points. And it's going to exit along the other asymptote. In along the asymptote, out along the asymptote. And that takes care of step 5. We've plotted our points and sketched the graph. Let's do another one. We've taken away the scaffolding now, so now we need to remember those steps on our own. Step 1 is a horizontal asymptote. Our numerator's degree is 0. The denominator's degree is 2. Since the numerator is less than the denominator, that means that the horizontal asymptote is the line y equals 0. So we'd start by graphing our horizontal asymptote, which is the x-axis, the line y equals 0. Okay, then we do vertical asymptotes. The denominator factors into x plus 3 and x minus 1, which means we have vertical asymptotes at x equals negative 3 and x equals positive 1. These would be the undefined values of the function. So we have a vertical asymptote at positive 1. That is not what I was expecting it to be. Vertical asymptote at x equals 1. And a vertical asymptote at x equals negative 3. Which means we have 3 sections. We have the section to the left of x equals negative 3. We have the section between x equals negative 3 and x equals 1. And we have the section to the right of x equals 1. So we have 3 sections this time. Now remember that the outside sections, when we make our table, the outside sections we're only going to need 2 points. So over here we only need 2 points. We're going to try negative 4 and negative 5 and hope that they work out nicely. Then from the middle section we need 3 points. Well, there's 3 integers between those two, so let's use those 3 numbers, negative 2, negative 1, and 0. And from the right section we need 2 points, so we're going to use the integers that are closest to that vertical asymptote, positive 2 and positive 3. So again, that's our left section, our middle section, and our right section. Okay, 3 points from the middle, 2 points from each side, hopefully will be enough. So we're going to go plug these in. So for negative 4, when we plug that in, the denominator would be 16, minus 8 is 8, minus 3 is 5, so y would be 2/5, 2 over 5. For negative 5, that would be 25, minus 10, which would be 15, minus 3 would be 12. That would be 2 over 12, or 1/6. So that should be enough for us to graph that section of the graph. Let's go ahead and put those points up there. Negative 4, 2/5 would be above the axis, but not very far above the axis. Be about a little under halfway. And then negative 5, 1/6, well, that is going to be closer to the axis, closer to the asymptote. So that tells us that our graph is coming in along that asymptote, passing through those points, and exiting along the asymptote up top. In the middle, when we plug negative 2 in up here, we get 4, minus 3, which is negative 3. So that's 2 over negative 3, or negative 2/3. When we plug in negative 1, that's 1. Minus 2 would be negative 1. Minus 3 would be negative 4. So 2 over negative 4, which is negative 1/2. Plug in 0, and we get negative 2/3. So again, in theory, that should be enough to give us our shape. We have -2, -2/3, which would be pretty much right on top of where it says -2 on the graph. -1, we're at -1/2, which would be just a little bit higher. And then 0, we're back down at -2/3 again. So what that's telling us is that it's coming in along the axis. It sort of looks like a parabola-ish shape. And then it exits down low again along that asymptote. Comes in along the asymptote and exits along the asymptote. Finally, with the right section, with 2 and 3, we plug those numbers in. When we put 2 into this function, we get 4. Plus 4 is 8, minus 3 is 5. So that would be 2/5. And then for 3, that'd be 9. Plus 6 is 15. Minus 3 would be 12. 2/12 reduces to 1/6. So it's going to look exactly like the piece on the left end, except a mirror image. 2 2/5, 3 1/6, and I'm kind of wishing those had been in purple, so I'm going to regraph those. 2/5, 1/6. So it's coming in from high along this axis or asymptote, and it's exiting along this asymptote. There's your graph. All right, let's do another one. That's 2 examples, so let's do a third. Okay, so horizontal asymptote. The numerator is degree 2. The denominator is degree 2. A and B are both 1 because there's no numbers in front of those x squareds. So our horizontal asymptote would be the line y equals a over b, which would be 1 over 1 or 1. So y equals 1 is our horizontal asymptote. Graph that line. That is our horizontal asymptote. Vertical asymptotes we need to factor. So we have x plus 1, x minus 1, and x plus 3, x minus 3. So for vertical asymptotes, we have x equals -3 and x equals +3. Both of those would cause division by 0, so both of those are vertical asymptotes. So we have one at +3 and one at -3. Okay, so that means that we have 3 sections again. So we need to pick 2 points from the left section. Let's go with -4 and -5 from the left section. We need 3 points from the middle section. We have 5 options, so let's go with -2, 0, and +2. And then for the right section, let's go with 4 and 5. It is technically possible that we might need to add additional prop points. We'll see what happens. So when we plug in -4, we have 16 minus 1, which would be 15, over 16 minus 9, which would be 7, which is 2 and 1/7. So just above 2. Right there. For -5, we have 25 minus 1, which is 24. And 25 minus 9, which is 16. That reduces to 3/2, or 1.5. So we are significantly lower. That tells us the basic shape is that it's going to come in along the asymptote and then exit up top. In the middle, -2 goes in here. That's 4 minus 1, which is 3, over 4 minus 9, which is -5. So that is -3/10, or -3/5, which is 6/10. When we plug in 0, we have -1 divided by -9, or 1/9. which is very, very close to the origin. It's 0.1 repeating units below that. And then for positive 2, we have 4 minus 1, which is 3, over 4 minus 9, which is negative 5, which is also negative 0.6. So we have negative 2, negative 0.6, 0, negative 1/9, 2, negative 0.6. So it's going to come in along the axis. It's going to pass through those 3 points, and it's going to exit back out along the axis on the bottom. Again, sort of looks like a parabola. We can't assume it'll always be that way, but it is. Then for the right side, we plug in 4. That's going to be the same number as negative 4. It's going to be 15 over 7 again. And for 5 will be the same number as negative 5 because we're squaring those numbers. The signs are irrelevant. That will be 3/2 again. So 4 15/7 would be 4 and 2 1/7 would be about right there. And then 5 1.5. So again, it's going to come in along that axis, pass through, or along that asymptote, pass through those 2 points, and exit along the horizontal asymptote. Okay, that does it for the second video. The third video is going to cover all those special case situations, oblique asymptotes, holes, and give a couple more examples dealing with those situations. Thank you very much for your time and attention.